Hi everybody, I wanted to work a question from the textbook that a student had asked about. This is question number 49 from chapter 14. Remember we're using the second edition of Tro, the atoms first approach. Alright, so the question is regarding a decomposition reaction. So we have AB decomposing into A plus B, and the data that was provided is time and then also the concentration of the reactant over time. So I've typed that already into Excel. And this question is asking us to determine the order of the reaction and the value of the rate constant. And then it asks us to predict the concentration of the reactant at time is 25 seconds. So the first part of this reaction is to determine, the first part of this problem is to determine the order. And we learned in this chapter, we can do this by plotting data. Remember that we studied zero, first, and second order kinetics in great detail. And if we pull up our handy dandy rate law summary table, we can see that if we plot the data, the correct y versus x, and if we get a straight line, then that will help us to determine the order of the reaction. Okay. And so the x-axis is always time here, but the y-axis is what changes, but it always involves the concentration of the reactant, which we do have. It's easy to manipulate it by doing natural log or 1 over the concentration. So that's what we're going to do. Okay? All right, so I'm going to move over and bring this forward here. The first thing I will plot is the concentration of the reactant versus time. So I'm going to insert chart. We always do X, Y scatter. And I'm going to select the data. Never trust the data here. I always want to select it myself. I know Excel wants to predict it for me, but just don't trust it. Okay, and the Y is just the concentration of the reactant. In this case, it's just AB. And it looks like this is what we have. And this would be zero order. And it's clear that since we do not have a straight line, that this is not following zero order kinetics, right? So what would we need to plot in order to see if it's following first order kinetics? Well, it looks like we would need to plot the natural log of the concentration of the reactant versus time. So I'm going to create a new column, natural log of AB, and I'm going to say equals the natural log of A, B, right there. I'm going to copy and paste it to fill the rest of the cells. There we go. I'm going to insert another XY scatter. I'm going to right click, select data, add a series, X values, time, Y values, natural log of the concentration of AB, and okay. I'm going to label so I know what I'm looking at when I'm comparing at the end. Natural log of AB, y-axis, x-axis is time. This also looks like it does not follow first order kinetics because it's not a straight line. So let's check out second order kinetics. What do I need to plot? 1 over the concentration of the reactant versus time. So 1 over the concentration of AB, and so I'm going to say equals 1 divided by the concentration, and then I'm going to copy and paste so I can fill in the rest of the cells. I'm going to do another XY scatter. That's going to look good. I'm going to just make sure that my series is good. It looks like it's already predicted it correctly for me, but just Just want to double check. Y is 1 over the concentration. And we have a very nice line here. So I'm just going to label my graph and then time. And this was second order kinetics. And then you can tell I just like to make them look nice, make them aesthetically pleasing. All right, if you ever have any doubt, you can add a trend line, which we would need to anyways, because we're going to use that for the next couple of parts. But you want to display the equation on the chart and the R-squared value, which tells you how good of a fit you have. R-squared close to 1 means you have a great fit, and look at that. 0.999999. That is awesome. So I'm going to write that equation down real quick because I know we'll probably need that in a second. Equals 0.0225x plus 1.059. Fantastic. All right, so just to review, recap, if you have to determine the order of a reaction in your given time and the concentration at specific points in time, and then you're expected to plot the data. The only thing you need to change is the y-axis, and to determine is it 0, first, or second order, and whatever gives you a straight line tells you what the reaction's following. This decomposition reaction is definitely following second order kinetics. All right, so let me share my iPad screen again. All right, so the question says determine the order. We definitely have second order. That's the first question. It then asks us what is the value of the rate constant. So if you pull up your rate law summary table, we follow second order kinetics. The units of the rate constant are provided here, and the slope of the line is equal to the rate constant. So that's why I wrote the equation down. So it looks like K is equal to 0.0225 inverse molar inverse seconds. So you can get that from the slope of the line. Now if it was 0 or first order, then the slope is negative K. So just be mindful of that. Then the last question says to predict the concentration of AB at 25 seconds. Anytime you're talking about the concentration of reactant after a certain amount of time has elapsed, then you're thinking I need to use the integrated rate law. Because the integrated rate law is the concentration of the reactants as a function of time. And so it's important that we determine the actual order so that we know which integrated rate law to use. So in this case here, we are using the second order integrated rate law. And we want to find the concentration of AB at 25 seconds is equal to KT plus 1 over the initial concentration. Looking back at our data, time is equal to 0 seconds. Our initial concentration was 0.95 molar, so you'd have to find that from the actual data. So I'm going to start to plug in. I'm going to plug this into my calculator. I got 1 over the concentration of AB at time is equal to 25 seconds, equal to 1.615, 13 molar. I'm going to take the inverse of that so I can get the concentration of AB at 25 seconds. And you should get equal to 0.619 molar is your final answer. So initially our concentration was 0.95 molar. After 25 seconds, we get down to 0.619 molar. Now, some of you may have been able to just look at the data and extract it out from there, and that's because you had data for 0, 50, 100, and so on and so forth. But for example, having the equation that we gathered from doing this linear regression analysis is useful. Let's say we were trying to figure out what's the concentration after 552 seconds, that's where it's useful. So try to use the equations and the integrated rate law in order to determine the concentration after a specific point in time, so that you know that you've done it accurately. All right, if you have any questions, please let me know. Hope you're all having a great day.